Minutes ago, Voyager 1 answered again. That should not feel normal. It is talking to Earth from a place so far away that even light needs almost a full day to cross the gap. One wrong command can cost 2 days. One bad reply can mean the end of a mission older than the internet, older than home computers, older than almost everything you now call modern. And yet, this machine is still out there, still whispering from the dark. What it survived, what it found, and what it is about to become may be one of the strangest chapters in the history of exploration. Stay with this story, because the final part is the part most people still do not understand. To feel how unreal this is, you have to start with the machine itself. Voyager 1 is not just another probe drifting through space. It is the farthest object human hands have ever built. It launched in September of 1977 when the world looked completely different, when a mission to the outer planets still felt like science fiction made real by sheer nerve. Engineers sent it upward on a Titan rocket, aimed it toward Jupiter and Saturn, and expected a brilliant but limited life. This was supposed to be a mission of years, not generations. Nobody at launch was planning for a spacecraft that would still be working nearly half a century later. Nobody was planning for a machine built with tiny amounts of memory by modern standards, running on old code, held together by aging parts and a shrinking power supply, to become humanity's only living witness in interstellar space. But Voyager 1 refused to end on schedule. It reached Jupiter and revealed a world of violence and beauty. It saw volcanoes erupting on Io, a moon that most people once imagined as just another dead rock. Then it raced onto Saturn and delivered views that changed textbooks, giving humanity a sharper look at rings, storms, and moons that had only existed as distant mysteries. After that, its path bent away from the flat plane where most planets move. It headed upward and outward, away from the familiar architecture of the solar system, toward a place no spacecraft had ever reached. That is what makes Voyager 1 different from almost every other mission you can name. Most spacecraft went somewhere, did their work, and slowly became relics. Voyager 1 kept going. It crossed the invisible frontier where the sun's protective bubble begins to give way to the wider galaxy. It became the first human-made object to enter interstellar space in 2012, which sounds like a simple line in a timeline until you stop and think about what that means. It means there's a machine, made by us now, moving through the region between stars. It means humanity has already touched the beginning of the larger ocean beyond our own solar neighborhood. That alone would have been enough to make Voyager 1 legendary. But then came the part nobody expected. On November 14, 2023, engineers at NASA's Jet Propulsion Laboratory sat down to look at the latest transmission. Voyager 1 had been sending back clean engineering and science data for decades. Not perfect, not effortless, but understandable. Then suddenly it was not. The signal coming home still had power. The spacecraft was still receiving commands. It was still alive in the most basic sense, but the data made no sense. Instead of clear engineering information about temperature, voltage, and system health, the spacecraft was returning a repeating pattern. To the people trying to read it, it was like hearing a familiar voice pick up the phone and speak in a language made of static. That was the true shock. Voyager 1 had not faded gradually into silence. It had not offered a long warning. It had not given anyone time to prepare for the end. It simply stopped making sense. In a mission where one round trip of communication takes nearly 2 days, that kind of failure is a nightmare. You cannot sit at a console and test ideas one by one. You cannot improvise in real time. You cannot ask the spacecraft what it means and wait a few seconds for an answer. Every message you send goes out into space for more than 22 hours before it even reaches the craft. Then you wait again for any response. If the command fails, if you guessed wrong, if the spacecraft reacts in an unexpected way, you do not learn that in minutes. You learn it days later. Imagine doing surgery while your hands are a day away from the patient. Imagine trying to fix an old machine across a gulf so large that the speed of light itself feels slow. That was the problem. For months, the team did not know exactly what had gone wrong inside the oldest working deep space spacecraft ever built. But here is where the story takes its first hard turn. Voyager 1 was not dead. It was wounded in a very specific way. Engineers eventually traced the issue to corrupted memory in the flight data subsystem, one of the spacecraft's onboard computers, the part responsible for packaging engineering and science data before transmitting it back to Earth. Think about how delicate that is. The machine could still hear. It could still respond, but the part of its mind that arranged its thoughts into something readable had been damaged, and the fix was almost absurd in its difficulty. The team had to rebuild the affected code, divide it into pieces, and move those pieces into different healthy areas of the spacecraft's memory. They had to update references so the old system could still find and use the new code. This was not a simple reset. It was a remote repair performed on a computer designed in another era, using documentation that in some cases stretched back to the 1970s, by engineers trying to outthink a failure occurring more than 15 billion miles away. Then came the waiting. In April of 2024, the team transmitted the first crucial commands. After the long one-way delay, Voyager 1 received them in the darkness beyond the planets. Then Earth waited again. On April 20th, readable engineering data finally began returning home. After 5 months of confusion, the spacecraft's basic health became visible again. You can say that in one sentence, but picture the room, picture the silence, picture people staring at screens, knowing that the result of weeks of reasoning and decades of inherited knowledge was now crossing billions of miles toward them. A message leaves Earth. A day later, it touches the spacecraft. Another day later, the answer arrives. And on that day, the answer was yes. The spacecraft could still speak clearly. It had not been lost. That alone would make this mission one of the great engineering stories of our time. But the rescue did not end there. Getting engineering data back was only the first step. Science data still needed to return. In May, the team sent more commands. 2 instruments resumed sending usable science data. Soon after, the remaining 2 were restored as well, and Voyager 1 returned to normal science operations for the first time since the crisis began. That is, the part many people miss when they hear a quick headline and move on. Voyager 1 did not merely survive a glitch. It came back to work. It resumed its role as a scientific outpost in a place no human being will ever personally visit. And this matters because while the spacecraft was surviving on borrowed time, it was also doing something no one else can do. It was measuring the frontier beyond the sun's main domain. It was listening to the interstellar medium itself. That phrase sounds technical, but the idea is simple. Space between stars is not truly empty. It contains thin gas, charged particles, magnetic fields, and waves moving through a darkness so vast it almost erases human intuition. For years, scientists had to infer what that place might be like using models, indirect signals, and theory. Voyager 1 changed that by physically going there. It crossed the heliopause, the boundary where the solar wind from our sun gives way to the wider galactic environment. And once it was beyond that line, it started to tell a stranger story than expected. One of the earliest surprises came from plasma. Scientists expected a change outside the heliosphere, but the readings forced them to sharpen their understanding of where Voyager had gone. Particle density jumped dramatically outside the boundary, showing that Voyager really had entered interstellar space. That was not just symbolic, it was physical confirmation that the edge of our solar neighborhood is real, even if it is not a neat wall. Then came an even quieter revelation. Voyager's plasma wave system detected a faint, persistent hum in interstellar space, not just bursts triggered by solar activity, but a steady background signal, a thin, monotone whisper from interstellar gas itself. That hum mattered because it meant scientists no longer had to wait only for powerful solar eruptions to probe local plasma density. Voyager could track the medium more continuously, offering a more direct sense of what kind of invisible environment it was moving through. But here is where things get strange. Crossing a boundary sounds like a clean event, inside and outside, before and after, protected bubble and open galaxy. That is how people like to imagine frontiers. A line on a map, a sudden switch. Yet the data from Voyager 1 kept resisting that simple picture. Researchers studying its magnetic field found something puzzling. The direction of the magnetic field around Voyager did not match the dramatic shift many expected just beyond the heliopause. Instead, the field seemed to be slowly turning. One analysis suggested the spacecraft was moving through a region where the local interstellar magnetic field was still being deflected by the nearby heliosphere, as if the sun's influence did not stop sharply at the boundary but continued to bend the environment around it. In plain terms, the edge of our solar system was blurrier than it looked in diagrams. The sun's protective bubble was not a hard shell with a crisp border. It was more like a frontier region, a zone of interaction, pressure, and distortion. That matters more than it might seem. It means that even after leaving what people casually call the solar system, Voyager 1 was still feeling the shape of home. The sun was still tugging at the structure of the space around it, not by pulling the spacecraft back, but by shaping the invisible magnetic conditions through which it traveled. In science, the most powerful discoveries are not always the loudest. Sometimes they are the moments when reality refuses to obey a neat model. Voyager 1 has done that again and again, and the farther it goes, the more symbolic the mission becomes. Because right now, Voyager 1 is racing toward a milestone that sounds almost poetic. In November of 2026, it is expected to become the first human-made object, one full light day from Earth. Think about that. Light is the fastest thing we know. It crosses Earth more than 7 times in 1 second. It reaches the moon in about 1.25 seconds. It gets from the sun to Earth in a little over 8 minutes. But for Voyager 1, by late 2026, even light needs about 24 hours to make the trip. When you send a signal to Voyager 1, you are throwing a thought outward so far that tomorrow arrives before your words do. That is not just a record. That is a new way of feeling distance. NASA's published estimates place that one light day mark in the early hours of November 18, 2026, at a distance of roughly 16.1 billion miles from Earth. The exact second matters less than what it means. Humanity has built many things: towers, ships, cities, networks, machines that circle our world, machines that touch the moon, machines that rolled on Mars. But nothing else we have made has gone this far while still calling home. And maybe this is the right place to ask the question hiding under all these numbers. What would it feel like to be the person reading that signal for the first time, knowing it began its journey yesterday, knowing it came from a machine launched before most people alive were born, knowing that one wrong bit of code could end a conversation that has lasted nearly 50 years? Would you feel triumph first, or fear? Because that is the emotional truth of Voyager now. Every success is mixed with fragility. Every milestone arrives with a shadow behind it. The spacecraft is powered by radioisotope generators that slowly lose output each year. The decline is steady, patient, unavoidable. Engineers have spent decades stretching that shrinking power supply, turning off heaters and shutting down instruments one by one, always asking the same painful question: what can we sacrifice now so the mission can live a little longer? In February of 2025, the cosmic ray subsystem on Voyager 1 was powered down as part of that long plan to conserve energy. In April of 2026, engineers shut off the low-energy charged particle instrument aboard Voyager 1 as well. That was not a symbolic change. It was a real loss. The instrument had helped measure ions, electrons, and cosmic rays in the interstellar medium. It had contributed to the structure of a place no other craft can sample, but the power margin had become too thin. The spacecraft had suffered an unexpected power drop during a routine roll maneuver. And the team knew they were nearing the territory where automatic fault protection could start shutting systems down on its own. Better to choose carefully than let the spacecraft choose under stress. After the April shutdown, Voyager 1 was left with two science instruments still operating: the plasma wave subsystem and the magnetometer. One listens to the whisper of plasma in interstellar space. The other measures magnetic fields in a region that still challenges theory. Two instruments. After all these years, after Jupiter, Saturn, the heliopause, the repair crisis, and the slow starvation of power, it still does science with two functioning voices. That is not much by the standards of a new mission. But out there, at this distance, it is astonishing. And here is the part that sounds almost impossible even now. NASA is not simply waiting for Voyager 1 to fade. Engineers are still trying to extend its life. In 2026, mission teams discussed and prepared a more ambitious power-saving strategy informally called the Big Bang. The idea is to change how certain powered systems are managed, replacing higher power configurations with lower power alternatives to keep the spacecraft warm enough and alive enough to continue operating. Voyager 2, which is closer and has a little more power margin, was expected to be the safer place to test that strategy first. If such efforts succeed, Voyager 1 may gain more time, perhaps even enough to consider short returns from systems once thought lost. There are no guarantees here. Nothing about a spacecraft this old and this far away is guaranteed, but the fact that people are still trying tells you what Voyager has become. It is no longer just hardware. It is an active relationship between generations of engineers and a machine that keeps exceeding the moment, written for its death. But here's where the story takes another strange turn. The title says Impossible Encounter. If you came here expecting alien contact, a hidden object in the dark, or some secret NASA does not want you to hear, the real story is quieter than that and somehow more powerful. Voyager 1's impossible encounter is with distance itself, with time delay, with survival, with the fact that a machine built in 1977 is still operating deep in interstellar space, still returning data that forces scientists to rethink the nature of the boundary around our sun. The impossible part is not that it found a monster in the dark. The impossible part is that it is still there at all, still doing work, still turning confusion into knowledge. And yet the science has its own kind of mystery. Consider that hum again, the steady drone of interstellar plasma. Consider the magnetic field turning more slowly than expected, as if Voyager had entered a zone where the sun's influence lingers in distorted form. Consider what that says about boundaries in the universe. We like clean edges because they comfort us. They make the cosmos feel organized. Here is the planet. Here is the system. Here is the line where one domain ends and another begins. Voyager 1 keeps reminding us that the universe is not built for our comfort. Frontiers smear, fields bend, pressure waves cross distances we struggle to imagine. The empty dark is not empty, and even the space beyond our sun still carries traces of its reach. That is why the mission matters scientifically. It is also why it matters emotionally. Voyager 1 does not just tell us what is out there, it tells us how little our first guesses captured. And if you think that is only interesting to specialists, step back for a moment. The heliosphere is the giant bubble created by the sun's magnetic field and solar wind. It helps shield the planets from some of the harsher conditions of interstellar space. Understanding where it ends and how it interacts with the galaxy beyond is not just a niche puzzle. It is part of understanding the environment that surrounds Earth itself. It is part of understanding what kind of cosmic weather our solar system moves through. It is part of understanding what protection means on a galactic scale. Voyager 1 is not reporting from nowhere. It is reporting from the outer edge of the neighborhood that made us possible. And this is where the mission becomes deeply human. Every transmission from Voyager 1 now feels like a gift from an elderly explorer who keeps finding one more reason to speak. The people maintaining it know this better than anyone. Suzanne Dodd, Linda Spilker, mission managers, flight engineers, scientists, system experts, all of them work in the shadow of limited power and long delays. They do not live in the fantasy version of this story. They live in the practical one, where every command has to be tested in the mind before it is sent, where old documents become survival tools, where a machine older than most laptops by decades can still outclass newer systems in one simple way. It keeps enduring. That is why moments like the 2023 failure hit so hard. It was not just a technical problem. It was the possible end of a conversation lasting longer than some careers, longer than many lives as adults, longer than entire eras of technology. And when the fix worked, the relief was not only professional, it was personal. There is something almost impossible to explain about keeping a 40-plus year relationship alive with a spacecraft you cannot touch, cannot see with your own eyes, cannot rescue physically, and cannot speak to in real time. It is engineering, yes. But it is also care. The team has to think in years ahead. Which instrument stays on? Which goes dark? Which heater matters most? Which margin can be risked? A choice made now may shape what science is still possible 2 or 3 years from now. That kind of thinking turns a mission into stewardship. You're not merely operating a spacecraft. You are helping it age with dignity while still asking it to work. And if you are still with me, here is the question that opens the final stretch of this story. What happens after the one light day milestone? Does Voyager 1 reach some grand finish line? Does it complete the mission in a neat cinematic moment and fall silent with perfect timing? No, that is the haunting part. One light day is only a marker. It changes the scale of the story, but not its direction. Voyager 1 will keep moving. It travels at roughly 38,000 miles per hour relative to the sun, fast enough to cross entire continents in minutes if it were flying through Earth's skies. It has been doing that for decades, and it will keep doing it whether we can hear it or not. In the early 2030s, the remaining science instruments may finally have to be turned off as power runs too low. After that, the transmitter itself may one day fall silent. No more data, no more engineering updates, no more whispers from the edge. That end could come sooner than people hope, or a bit later if clever power management keeps the craft alive. But it will come. That is the bittersweet truth of Voyager 1. We are living in one of the final active chapters right now. The story has not ended, but the last pages are in view. And yet, even that is not the final ending, because a silent Voyager is still Voyager. Even after the instruments go dark and the carrier signal fades, the spacecraft itself will continue outward for tens of thousands, then millions of years. Physics does not stop because our conversation stops. The craft will drift through interstellar space with the golden record, still on board, carrying greetings, sounds, music, diagrams, and fragments of Earth. That record was never a realistic plan for contact. It was a statement, a bottle in a cosmic ocean. A declaration that a young technological species once stood on a small world and wanted to be known. In about 40,000 years, Voyager 1 is expected to pass within about 1.6 light years of a star called Gliese 445. That sounds close until you realize it is still an unimaginable gulf. There will be no dramatic meeting, no handshake with another civilization, no sudden answer to whether we are alone. Just a silent machine moving past a distant star on a path that has no practical destination. But maybe that is exactly why the mission feels so large. Voyager 1 is not chasing a final prize. It is bearing witness to persistence itself. It is proof that humans can build something fragile and send it farther than seems reasonable, then refuse to abandon it when it begins to fail. It is also worth remembering that Voyager 1 is not alone in spirit. Its twin, Voyager 2, launched weeks earlier in 1977, is also in interstellar space, also still communicating, though from a lesser distance. The two spacecraft followed different paths because NASA made different choices for them. Voyager 1 took a route that sent it more quickly outward after its close look at Saturn and Titan, while Voyager 2 followed the grand tour path to Uranus and Neptune, becoming the only spacecraft to visit both. One went faster and farther, the other went wider and deeper across the outer planets. Two old explorers, each with a different legacy, both now drifting beyond the familiar domain of the sun. But Voyager 1 remains the leader in raw distance. And that distance is becoming almost poetic. A machine, born in the age of rotary phones, is approaching a communication delay so vast that an ordinary greeting becomes a 2-day exchange. If that does not force you to rethink scale, nothing will. Space stories often get flattened into spectacle. Bigger, planet. Brighter image, stranger headline. Voyager 1 resists that flattening because its drama unfolds in slowness. Nothing about this mission is instant now. Discovery takes patience. Repair takes patience. Meaning takes patience. The spacecraft is not giving us quick thrills. It is giving us the long view. It is forcing us to respect time, distance, uncertainty, and the fact that knowledge at the frontier often arrives in faint signals that only become important when someone cares enough to keep listening. That may be the deepest lesson of all. Human progress is not only rockets and launch days and first steps. Sometimes it is maintenance. Sometimes it is decoding gibberish from a damaged computer billions of miles away. Sometimes it is turning off one beloved instrument so 2 others can survive. Sometimes it is accepting that the most heroic act is not starting a mission, but keeping it alive long after it should have ended. Voyager 1 embodies that version of exploration better than almost anything else we have ever built. So what has it really changed? It changed how we understand the threshold between the heliosphere and interstellar space. It gave direct evidence about plasma density beyond the heliopause. It revealed a persistent background hum in interstellar plasma. It helped show that the local magnetic field just beyond the sun's protective bubble behaves in ways more complex than simple models predicted. It keeps reminding scientists that the outer edge of our solar environment is not a cartoon line, but a dynamic, distorted borderland. Those are real contributions, measurable, verifiable, quietly profound. But the bigger change is harder to write in a paper. Voyager 1 changes the way we imagine ourselves. It shrinks us, yes, because its distance is humbling. Yet it also enlarges us because it proves what our species can do when curiosity lasts longer than convenience. A civilization that often struggles to think beyond election cycles, product launches, and short headlines built a machine in 1977 that is still doing frontier science in 2026. That means we are capable of more long thinking than we often admit. We are capable of building for futures we will not personally see. We are capable of sending questions farther than our lifetimes. And maybe that is why the mission feels emotional even to people who do not follow every technical detail. Voyager 1 is old. It is fragile. It is far away. It nearly lost its voice. It got it back. It is still speaking. Those facts land like a story because they are a story, not a made-up one, not a fantasy about impossible creatures lurking in the void, but a real story about persistence against a universe that offers no mercy and no shortcuts. That is more moving than fiction because it actually happened. Somewhere beyond the planets, beyond the heliosphere, beyond the reach of any rescue mission, a small machine still turns experience into data and throws that data home across a gulf of darkness. Earth listens. The Deep Space Network catches the signal with giant radio dishes spread across the planet. Engineers decode it. Scientists study it. Another day passes. Another command goes out. Another answer may come back tomorrow. This rhythm has been going on for decades. There's something sacred in that rhythm, even if you do not like the word sacred. It is a conversation stretched across space and time, held together by mathematics, radio waves, plutonium heat, and human stubbornness. If we lose that conversation in the next decade, and we probably will, the loss will not just be scientific. It will feel like the end of a voice we grew up with without noticing. The world is full of noise, and Voyager 1 is the opposite of noise. It is faint, distant, deliberate, and real. Maybe that is why the milestone ahead matters. Not because one light day is a magical threshold in physics, not because crossing it unlocks some hidden chamber of the cosmos, but because it gives us a moment to notice what is already extraordinary before it is gone. Right now, while most people go about ordinary days, a spacecraft built before they were born is nearing the point where even light takes a full day to travel between it and the world that made it. Right now, it still has 2 science instruments alive. Right now, it is still telling us about magnetic fields and plasma in a place no other active mission can reach. Right now, each packet of data is both science and farewell. This is not the end yet, but it is close enough that every success feels tender. And perhaps the most honest wonder in this story is not that Voyager 1 found something impossible in deep space. It is that humanity built something so brave and so durable that deep space still has to answer back. Long after Jupiter, long after Saturn, long after the official mission should have ended, long after the first engineers retired and new generations took over the watch. Voyager 1 keeps going, it keeps finding, it keeps surviving. One day, maybe sooner than we want, its final signal will leave the spacecraft and begin the long journey home. A day later, Earth will hear it, and there will be no next reply. The conversation will be over, but even then the story will not truly end. Voyager 1 will still be out there, carrying our golden record into a darkness that does not care and yet has been forever changed by the fact that we reached into it at all. That is the real encounter. Not with aliens, not with an impossible beast hidden between the stars, with scale, with silence, with endurance, with the simple, astonishing truth that a machine built by a restless species on a small blue world crossed the edge of the sun's domain, nearly died, recovered, and is now approaching a distance so extreme that tomorrow is how long it takes light to say hello. And somewhere in that cold, black ocean farther from home than anything we have ever touched, Voyager 1 is still listening, still speaking, still proving that the line between impossible and achieved is sometimes nothing more than the distance a signal can survive.